All right. Hi, everyone. Thank you for joining the event today. So my name is Kuhn Peng, and the Vice President of Stanford Blockchain Club, and also founding director of the Stanford Blockchain Accelerator Program. So we're trying to incubate Stanford startups in a more crypto native way. So today we're doing an event with Avalanche team as part of this accelerator education series. So today we have the pleasure to have Gabriel Cardona from Avalanche, and later on we'll have Patrick joining us as well from Avalanche, and also he's actually a CS master in Stanford University. So that being said, I will let Gabriel to do a self-intro. So go ahead.
Thanks. Can everybody hear me okay?
Yes.
Excellent. Thank you so much for having me first. It's a great honor. So I think we're going to go ahead and get started. My name is Gabriel Cardona, and I am developer evangelist at Avalanche Labs. And as Kuhn mentioned, I will be joined in a minute by Patrick O'Grady. Patrick is our VP of engineering. He's running a couple minutes late. And then so today I'm going to be giving a presentation called Subnets and Virtual Machines, where we're going to be talking about who we are at Avalanche Labs, what we've been building, and then we think there are really 4 paradigm shifts that make Avalanche a leap forward in blockchain technology. But let me go ahead and share my screen with you guys. Give me one second. Oh, you have disabled screen sharing.
Let me make you actually a host.
Sure,
so
thank
be
you.
able to, yeah. And also, in case people have questions, can they just ask a question whenever you're presenting?
Sure, yeah, you can ask a question. If I don't answer it immediately, I'll sweep back to it, or we can, we're definitely going to do a Q&A at the end. So either way, we'll definitely get to your questions.
Okay. Yeah, you can either raise your hand, unmute yourself, or throw the question to the chat.
Perfect.
You should be able to present your screen.
Okay. Yep, perfect. Okay, so I'm now going to share my screen. You can see it, yes?
Yes, we can see it.
Okay, excellent. So I'm going to go ahead and present here. So as I mentioned, my name is Gabriel Cardona. I am developer evangelist at Avalanche Labs. Today's presentation is called Subnets and Virtual Machines. We're going to speak briefly about who we are at Avalanche Labs, what we have been building over the last couple of years. If we have time, we're going to talk about some highlights from our ecosystem, but primarily I want to discuss 4 different attributes of our system, which we believe make Avalanche a genuine leap forward in blockchain technology. So, quickly, who is Avalanche Labs? Avalanche Labs is a world-class team of experts in the fields of computer science, economics, law, and finance. And we have offices primarily located in New York City and Miami, but we have team members all over the world. So myself, I'm based in the San Francisco Bay Area, and we have people all over the world, not quite every continent, but nearly every continent. To kind of drill down on our team, as I mentioned, we are passionate individuals with a vision to create a frictionless world by redefining the way that people build and use finance applications. And the Avalanche Labs team has collective experience from leading Fortune 500 finance and tech companies all the way to high growth blockchain companies and startups. And that's really where we are in the chapter of our life cycle right now. We are a high growth blockchain startup. I believe that we are just now about to cross 50 people on our engineering team. And I think the whole company is around 130 or so. And we are just growing absolutely rapidly. We're hiring across the board. So it's an incredibly exciting time to be at the team. To be on the team. So just to drill down a little bit onto our C-suite, simply because they're all such incredible gentlemen. Our CEO is Professor Amin Gun Sarir, and he has been a professor at Cornell for over 20 years. And his accolades are really too many to name, but something that I think is pretty cool is that he was one of the creators of the very first virtual currency for peer-to-peer systems, and this was called Karma. So back in 2003, 5 or 6 years before Satoshi released Bitcoin, Goon and some co-workers created something called Karma, which was a peer-to-peer virtual currency, which is pretty cool. Below him is John Wu. John is our president. John attended Harvard and Cornell and was previously co-founder of Sego or Shoreview Capital. Our COO is Kevin Seknicki. Kevin is a PhD from Cornell and was previously at Microsoft and at NASA. And then lastly, our chief protocol officer is Ted Yin. Ted is also a PhD from Cornell. He just got his PhD maybe like 8 weeks ago. Congrats, Ted. And what also many accolades, but one of them worth mentioning is that Ted is the co-creator of Hot Stuff. And Hot Stuff is the classical consensus protocol that's used by Facebook's Libra or DM network. So, he helped create Hot Stuff, and now he's working as our chief protocol officer. And then, of course, briefly, who am I? As I mentioned, my name is Gabriel Cardona. I'm developer evangelist at Avalanche Labs. I currently help maintain Avalanche JS, which is our TypeScript JavaScript library. And I also help maintain Avalanche, which is our local development network. And then I also am the organizer of our developer relations squad. So I go around to conferences and conventions and hackathons and meetups like this. And I give presentations with the intention of inspiring people to build, amazing things on the Avalanche network. And, just about myself, I really do believe, I genuinely believe that there is no more valuable resource on the entire planet at this exact moment than a really competent, hardworking, creative engineer. And the reason I feel that way is because I believe that we're at this unique time in our species where we need to solve problems at scale and velocity. And, fortunately, there have been so many paradigm shifts in computer science and engineering going back 150 years or so, going back to Ada Lovelace and Charles Babbage and the difference engine and the analytical engine. If you go back there and fast forward until now, there have just been so many new tools that we have a tool set available like unlike any time in human history. So really what we need now is, hardworking, competent, and smart people and creative people to step forward and build the systems which solve the problems. So that's really why I do what I do. And, hopefully I can inspire you to build something and to build it on Avalanche. And as I mentioned, of course, we are hiring. So if anything I say today, sparks a spark in your brain, you can check out avalabs.org. We're hiring in biz dev, engineering, marketing, operations, product. So check out avalabs.org/careers or hit me up at the end. My contacts are there. Okay, so now finally, let's get into what this is actually about. So, what is Avalanche? So Avalanche is a global financial network for the issuing and trading of all digital goods. And we enable potentially millions of validators to process thousands of transactions per second with near instant finality using a protocol which is completely green and quiescent. And we have paired this extremely high throughput, very fast finality protocol with an architecture that can meet the needs of unique financial services and decentralized applications. And we accomplish this through this notion of subnets or subnetworks. And so subnets allow anyone, anywhere. I hear somebody talking. We good? Okay. Subnets allow anyone, anywhere to spin up a tailor-made network with custom virtual machines and complex validator rule sets. So we're going to dig into that a little bit. Custom validator rule sets and complex virtual machines. So Avalanche is really a network of networks. Avalanche is a platform for launching platforms. And we envision thousands and thousands of these public and private networks all emerging into this marketplace, which we are calling the Internet of Finance. Oh, what happened there? I don't think I'm able to control. There we go. Yeah, not sure what happened. Okay, so I'm back on track. So yeah, I want to give a brief history on the evolution of the blockchain revolution. I suspect that most of this information isn't going to be, shocking news to anybody who's watching this right now. But I have discovered that to really appreciate where you're going, it helps to understand where you're coming from. And so I want to briefly step through a couple iterations of the blockchain revolution to sort of build into why we believe Avalanche is genuinely a leap forward in blockchain technology. So blockchain 1.0 was Bitcoin. So, in the beginning was Bitcoin and the Bitcoin was good. And Bitcoin really proved to the world that there was the need for a robust and a decentralized payment network. And Bitcoin is amazing. Bitcoin really was a genuine paradigm shift. It changed many people's lives, myself included, pretty radically. As I mentioned, I found out about Bitcoin in 2011, and it changed the direction of my career and my life, that's for sure. But as big of a leap forward as Bitcoin was, of course, it has downsides. And so, namely, the downsides of Bitcoin are that it is slow. So for the sake of this presentation, I'm referring to the layer 1 Bitcoin network. I'm not, of course, referring to the Lightning Network or anything layer 2. I am, of course, aware that those things exist. For the sake of this demo, for this presentation, I'm strictly referring to the Bitcoin layer 1 network. BTC, the network, is slow. It only does a handful of transactions per second. It does not have fast finality. So, you have to wait 6 blocks. Each block is around 10 minutes. So it takes about an hour before you're confident that your transaction is not going to be double spent. It has a scripting language. It's called Script unimaginatively. It's very archaic and old school. It's cumbersome to use. It doesn't feel modern. If you've ever worked with a modern language, it feels like a step backwards when you're writing smart contracts in Script. Bitcoin does not have tokens. So yes, it has an op return op code that allows you to write 80 bytes of arbitrary data to the chain, and you can encode asset issuance and management commands into this 80 bytes. And you can write wallets which parse that data and make sense of it. However, the tokens are not miner validated, so they leave a lot to be desired. So, as great as Bitcoin was, it left a lot to be desired. And so there was blockchain 2.0, which of course is Ethereum. And Ethereum is a decentralized app which allows developers to launch their own decentralized apps on top of it in the form of a smart contract. And the reason this is a big deal is because you have to realize that prior to Ethereum, if you wanted to launch your own decentralized app, then you really had to roll your own network. There's Patrick waiting to be let in, by the way. So prior to Ethereum, if you wanted to launch your own dApp, then you had to launch your own network. Hey, Patrick, welcome to the party. By the way, everybody, that's Patrick OGrady. He is our VP of Engineering. Thanks for joining us. If anybody has any questions, feel free to cut in. Patrick, if you want to chime in anywhere, obviously, just feel free to jump in at any moment.
Let's see here.
Yeah, we can hear you.
There we go. Can you see me all right? All right. Sorry about that, guys. I'm a little late here. I didn't mean to interrupt you, Gabriel. Go ahead.
No, all good. I don't think I can't see you, but I'm sharing my screen. But either way, feel free to jump in if you want to add something or correct something. So basically, by enabling developers to launch on top of Ethereum, it enabled a network effect. And this led to a huge wave of innovation around, obviously, tokens and ICOs and NFTs and DeFi and yield farming and prediction markets, DAOs. Just so much innovation came from the network effect of Ethereum, allowing developers to launch their own decentralized apps in a form of smart contracts on top of it. Let's see here. We think of Avalanche as blockchain 3.0 technology, and similar to blockchain 1.0 and blockchain 2.0, there are a handful of new paradigms which we're going to talk about today. So the first being Avalanche Consensus. We think that Avalanche Consensus is the third major paradigm in the field of consensus. There's network of networks. So unlike so-called traditional blockchain networks, such as Bitcoin, where you have one virtual machine and one set of validators, Avalanche is actually a network of networks. We have virtual machines, which are the application level logic of a blockchain. And then we have subnets, which, as I mentioned, are dynamic sets of validators. And so we're going to touch on each of those now. So first is Avalanche Consensus. Excuse me. If you work in the blockchain space, you likely hear the word consensus 1,000 times a day. So what is consensus? Consensus is simply the process by which a set of independent validators come into an agreement on a decision. So at a super high level, consensus is just getting people to agree on a decision. And as I mentioned, consensus is a very rich field of computer science. It goes back at least 30 or 40 years to the 70s and 80s. And in the first paradigm was called classical consensus. And classical consensus has extremely high throughput and fast finality, and it's very green, but it's not scalable and it's not robust or decentralized, and it performed poorly, I should say, in adversarial conditions. In 2008, 2009, when Satoshi Nakamoto launched Bitcoin, pardon me, the world was introduced to Nakamoto Consensus. And Nakamoto Consensus, of course, is very scalable and robust and decentralized, but it doesn't have fast throughput, right? A handful of transactions a second. It doesn't have fast finality. It takes an hour for you to be confident your transaction is not going to be double spent. It's not green or lightweight. We all know the meme that Bitcoin BTC burns more energy than some nation states every day. And it performs okay in adversarial conditions at the 51%, famous 51% attack. Well, in 2018, a pseudonymous group of developers known as Team Rocket released a white paper on IPFS, introducing the world to a third paradigm of consensus known as Avalanche Consensus. And Avalanche Consensus is really the perfect storm of features from both classical and Nakamoto Consensus. It's scalable and it's robust. It's very decentralized. Today, we have over 1,100 full block and vertex producing validators on our mainnet, over 1,100 today. In theory, there could be millions of validators. Obviously, that's a theoretical limit at this point, and it's not been tested. But it's incredibly decentralized and robust. It has very fast throughput, thousands of transactions per second, or high throughput, I should say. It has fast finality, about a second or less, sub-second, immutable, irreversible finality. So there's no such thing as a reorg attack on Avalanche. And about the length of the blink of a human eye, that quickly, your transaction is settled, and it is settled for good. There's no reorg. There's no double spin attack. It's very lightweight and green and quiescent. It can be run on a PC, a VPS, drop it on the cloud, a Macintosh. Previously, it used to run on IoT devices. Recently, the hardware requirements went up a little bit, and it no longer runs on many IoT devices. But that's definitely on a vision of the team to be able to run the full node software on an IoT device. So hopefully the hardware requirements will come down again as time passes and the engineering matures and hardware catches up, all those good things. And then Avalanche Consensus is parameterizable, so it performs well in adversarial conditions up to, I think, 81 or 88%, something like that. So I have this really cool visualization created by Ted, our chief protocol officer. Really quickly, technically, Avalanche is a metastable consensus protocol inspired by epidemic protocols and gossip networks. The process used to determine whether a transaction is preferred or not is referred to as repeated random subsampling. So here we have this demo, as I mentioned, created by our chief protocol officer, Ted Yin. As I mentioned, Ted was one of the creators of Hot Stuff, the classical consensus protocol behind Facebook's Libra or DM network. And now he's working on Avalanche Consensus. And in this demo, each one of these squares represents a node in a network, and the color of each square represents the node's current proposal. So in this case, we have a binary decision. Is this transaction orange or is it blue? It's worth noting that Avalanche Consensus can do non-binary decisions, but for the sake of developing an intuition about it in this context, it's binary, orange or blue. The darkness of the color shows the node's conviction in that proposal. And so when I press play here, the nodes are going to start repeatedly randomly subsampling their peers, and they're going to change the color and the conviction of their proposal based on what their peers say. Let's see if this works. And you can see what's cool is it only takes a couple rounds of sampling, and the whole entire set will actually tip and then avalanche into consensus. Let's see if we can watch that one more time. It's a thing of beauty.
I've sat and watched this demo for hours at a time. I don't know what it is about it, but yeah, Ted's not even a UI guy. But I don't know. He showed me this, and I was convinced otherwise. But yeah.
Yeah, he did so good. It's beautiful. So yeah, there you go. Hopefully that develops a bit of an intuition for you around how Avalanche Consensus works. So now let's talk about network of networks. So as I mentioned, Avalanche is different than so-called traditional crypto networks, such as, let's say, Bitcoin or Ethereum, where you have one virtual machine and one set of miners or validators. In Avalanche, you actually have a network of networks and this idea of compound network effects. So I very briefly want to dig into network effects and compound network effects. Most people are familiar with network effects. It's Metcalfe's law. I suspect many people on this call are familiar with that concept. And basically, it just says that a network's value is proportional to the square of the number of nodes in the network. So for example, if a network has 10 nodes, its inherent value is 100, right? 10 times 10. So in other words, a product or service gains additional value as more people use it, right? Everybody is on X social network because everybody is on X social network. Everybody's building on Avalanche because everybody's building on Avalanche. And it's this cycle, it's like gravity. And it builds on, it's a cycle that builds upon itself. So as it attracts more people to itself, it becomes more powerful and attracts more people, that kind of thing. And there's a couple canonical examples, the telephone network. So if only one person has a phone, it's not very useful. For each additional person that plugs into the network, the entire network becomes more valuable for every other person because everybody can call everybody. Perhaps a better example, of course, is just money. If only one person accepts a currency, it's not that valuable. For every additional person that accepts a currency for a good or a service, the entire currency becomes more valuable for every other person. And so that's network effects, Metcalfe's law. But there's something called Reed's law, which is compound network effects, which I interpret to be like amplified network effects. And so Reed's law says that the utility of large networks, particularly social networks, can scale exponentially with the size of the network as the number of possible subgroups grows much more rapidly than either the number of participants or the number of possible pair connections. Even if the utility of groups available to be joined is very small on a per group basis, eventually the network effect of potential group membership can dominate the overall economics of the system. So this is called Reed's law. I encourage you to check it out and read it if you weren't able to, capture that all in your brain, but it's like amplified network effects. And so Avalanche subnets with the ability to do cross subnet asset swaps, they're really designed and primed for compound network effects. And so we have this great visualization from CryptoSec on Medium and on Twitter. It kind of gives a sense of the gray oval is the Avalanche network. Inside of it, you can see the circles. Those are different subnets. Some of them are public, some of them are private. Inside of them, you have different green squares, which represent different virtual machines. And then you have lines, so you can represent asset swapping between the different virtual machines. And then you have bridges out to other layer one networks, such as Ethereum and Bitcoin and Cosmos up at the top. So this kind of gives you a sense of when we say Avalanche is heterogeneous means rich and diverse in character. Avalanche is a very, very rich and diverse in character network. So next we want to talk about virtual machines. A virtual machine defines the application level logic of your blockchain. And in technical terms, a virtual machine is a state machine. So it specifies the blockchain state transition function, transactions, and an API through which users can interact with your blockchain. And every single blockchain on Avalanche is an instance of a virtual machine. And as a developer, when you write your decentralized app as a VM, you don't have to worry about underlying low-level logic like networking. You don't have to worry about underlying consensus. You don't have to worry about the underlying structure of your blockchain. Avalanche does all of this for you behind the scenes, so you can just focus on the special sauce that makes your dApp unique. And so you can think about a virtual machine as the blueprint for a blockchain. And you can use the same virtual machine to create many blockchains, each of which follows the same rule set, but are logically independent of other blockchains. And a good way to think about this is like object-oriented programming. So if you're familiar with a class, you can use a class to spin up a bunch of different instances of objects. Each of those objects follow the same rules, but they're logically independent of each other. They're all instances of the class. It's the same thing in Avalanche. You can have a virtual machine like the Ethereum virtual machine, and you can instantiate it a bunch of different times. Each of those blockchains will follow the same rules, but they'll be logically separate and independent from each other. So why would you want virtual machines? We briefly touched on this earlier. In the beginning, blockchain 1.0 and 2.0, the networks only had one virtual machine with a predefined static set of functionality. So this rigid monolithic design limited what blockchain developers, what applications could run on such networks. And people who wanted custom decentralized apps had to create their own entirely new blockchain network from scratch. And so as I mentioned before, this takes a ton of time and effort, offers limited security, and resulted in a very bespoke environment where few of these networks were able to get the network effects required to tip and go mainstream. And again, Ethereum made a huge leap forward by allowing developers to launch their smart contracts on top of it. And this, of course, led to a network effect. But the Ethereum virtual machine still has low performance and imposes restrictions on smart contract developers. So even though Ethereum solved the problem of the network effect, it's still challenging to create decentralized applications. So for example, Solidity and Viper or any of the other languages for writing Ethereum smart contracts are unfamiliar to most developers. And so, you can think about it, you spend your day writing Golang or TypeScript or C++ or Python, and then you go to a domain specific language like Solidity for writing smart contracts, and it's very cumbersome and archaic, and it's not that pleasant to use. Avalanche's virtual machines make it easy to define a blockchain-based decentralized app. And rather than new limited languages like Solidity, developers can write virtual machines in Go today. And then we also have a gRPC interface that if you can implement this interface, you can write your virtual machine in any language which can implement that interface. So we have this custom virtual machine called the Chain RPC VM, which allows you to run your virtual machine in a separate process than the main Avalanche Go process. And you can wrap your virtual machine as a gRPC server and then run a gRPC client in the main Avalanche Go process, and then make calls, request and response. So you can actually implement your virtual machine in whatever language you're used to working in every day, which is a huge, huge, huge leap forward. No question about that. Next, we want to talk about subnets. So subnets, or a subnetwork, is a dynamic set of validators working together to come into agreement on the state of a set of blockchains. And each blockchain is validated by exactly one subnet, and a subnet can validate many blockchains, and a node can be a member of many subnets. So I'm gonna throw this data visualization at you. So open your mind up to this. This is multidimensional here. So this is how the whole system fits together. A virtual machine is the application level logic of your blockchain. It's like a class in object-oriented programming. A virtual machine can be instantiated into a blockchain. One blockchain is an instance of a virtual machine, and one virtual machine can be instantiated into many instances of many different blockchains. So one blockchain is validated by exactly one subnet. One subnet can validate many different blockchains, including many different instances of the same virtual machine. One node can belong to many different subnets, validating many different blockchains, including many instances of the same virtual machine across different public and private subnets. So if you were able to follow all that, that was a lot, I know. That's why we say Avalanche is heterogeneous, right? It's very rich and diverse because there's a lot going on there, as you probably just picked up. And so subnets can manage their own membership, and they can require that constituent validators have certain properties, which can be useful for several things, such as regulatory compliance, right? Avalanche's subnet architecture makes regulatory compliance manageable, as the subnet can require validators to meet certain requirements. So for example, you can say, every validator in my subnet has to be located within a certain legal jurisdiction. Every validator in my subnet has to pass certain KYC AML checks. Every validator in my subnet has to hold a certain license. Every validator in my subnet has to meet certain hardware requirements, and et cetera, et cetera. We also have support for private blockchains. So you can create a subnet where only certain predefined validators can join, and you can actually create a private subnet where the contents of the blockchains would be visible only to those validators. So of course, this is ideal for organizations interested in keeping their information private or for checking off regulatory compliance checkboxes. There's also separation of concerns. In a truly heterogeneous network, some validators are simply not going to want to validate certain blockchains because they just don't care about what's happening on those blockchains. The subnet model allows validators to only concern themselves with blockchains that they care about, and this reduces the burden on different subnets and different validator sets. You can also have application-specific requirements. So different blockchain-based applications may require validators to have certain properties. So for example, suppose there's an app that requires large amounts of RAM or CPU. A subnet can actually require that validators meet certain hardware requirements so the application doesn't suffer from low performance due to slow validators. So, okay, cool. We're right on time. So it has now been 27 and a half minutes. I know we had talked about checking in at a half an hour to bring in Patrick a little bit more, and then also to start addressing some Q&A. So really quickly, I just want to jump to the very end here and say, my name is Gabriel Cardona. I'm developer evangelist at Avalanche Labs. You guys can hit me up on Twitter or Telegram at CG Cardona. If anything I talked about today seems cool and you want to follow up on something, feel free to reach out to me. Thank you so much for having me. So now I wanted to bring in Patrick a little bit and let's do some Q&A.
Yeah, thanks for doing all this, Gabriel. Gabriel actually asked me if I wanted to lead this thing, and Gabriel's been doing this talk so many times and has all these like great images and all these great segues. This is honestly the first time I'm learning about Reed's Law, so I have to say that, you know, pretty impressive with
Nice.
the stuff you had there. And yeah, thanks for leading that off. And also thanks for inviting me as well to kind of participate here. I don't know, you know, how these usually work, or if I should introduce myself a little bit, or what I can do here to say hi. Yeah.
Sure. Thank you, Gabriel, for the presentation. So I think what we'll do is we actually have collected some questions ahead of time through a Google form. I'm gonna ask some of the questions, and also if anyone from the audience have any question, feel free to raise your hand or unmute yourself, or throw the question to the chat. Actually, there are already a question.
Cool.
So how does Avalanche Subnets compare to Polkadot parachains?
Great question. Yeah, so before I get started, actually, let me just briefly introduce myself a tad, of kind of, just so you know, people that don't know us and don't know a little bit about what we do. I'm Patrick O'Grady. I'm the Vice President of Engineering here at Avalanche Labs. So if there's something up with the network, or there's something that you want better and it requires some engineering work, usually I'm the person involved with that. I graduated from Stanford in 2019. I started 2014, so it took some meandering roads there, as many of you I'm sure are, doing random startup-y things. After that, I worked at Coinbase for a few years on the crypto engineering team. And then from there, went to Avalanche Labs, and so have been working here for about 11 months now. From that perspective, that's where I'm coming from. Obviously, I'm a huge Avalanche fan and, you know, Avalanche Labs fan, so take that with a grain of salt. But yeah, so Polkadot parachains versus what we do with subnets. So the way I typically explain it is, you know, Avalanche subnets are this interesting medium between Polkadot parachains and Cosmos zones. And so Polkadot parachains, in general, right? I think the first auction actually closed yesterday or early this morning for their first parachain. I think it was called Akala, something like that. And that was competing against Moonbeam, and Moonbeam, I think, is an EVM compatible thing. I'm not quite sure what Akala does, but I think it was something like $1.3 billion locked up, or something along those lines. Parachains, Polkadot as a whole is, think of it in an abstract way as like a WASM blob executor. So they have a very restrictive SDK framework where an application developer can write a WASM, like typically in Rust, something in Rust that compiles down to WASM that can then be run by different subsections of the validator set that are then checkpointed basically to what they call the relay chain, is their main chain. Now, Polkadot parachains are a fundamental part of the Polkadot like consensus mechanism. And so they're checkpointed to like the actual relay chain blocks on a regular cadence. I believe it's something around every 6 seconds. And validators are randomly assigned to each parachain during what they call, I think, our eras. So something like every 24 hours. Now, with that mechanism, 2 things really pop out there. Well, 3 things really. 1, to become a proper parachain, you have to deposit a lot of, like, lock up a lot of DOT. And now that can be done by the ecosystem as a whole. And you're basically taking that DOT out of circulation for that time, and it's not inflating. So like the payment for the parachain is basically the loss of rewards you get on that total, total stake that you've locked up. But really what's going on with these parachains is it costs a lot of money to kind of get it going or locked up. 2, it's very restrictive. Like I mentioned, it has to be a WASM blob. And because it's so foundational to the consensus, such that any validator may be assigned to it and have to sync it, there's a lot of restrictions around like execution and how much execution you can do in a certain interval. And then 3rd, as a validator, you don't have a choice of which parachains you may participate in at any given time. Avalanche subnets, I'll explain next, and then kind of probably I'll stop there because I don't want to answer a question that wasn't really asked. Avalanche Subnets, very similar to the idea of like a parachain where you can have a dynamic group of validators, but instead of being assigned to that subnet for some period of time and then rotating off, anyone can join the subnet as long as you're an Avalanche validator. So that's like the longer term idea, where you have these permissionless subnets where you can stake some sort of native token to a subnet that would grant you entry to participate as like some sort of staker. Right now, typically people do like a proof of authority style. So a subnet creator will create, let's say that, I don't know, I create Patrick Net and I build it on top of Avalanche. I'm going to create a subnet that only costs me 1 Avox. I think that's like $100. And then from there, I can add validators. People maybe I know offline, or people that, you know, have reached out and said, hey, I'd love to participate. And then I can add them to my network. They don't have to do it. They can just say like imagine like, I don't know them. I'm like, hey, you'd be a good validator. I'll add you. They don't have to participate if they don't want to. But the thing that really gets me excited is the flexibility of our virtual machine concept compared to some of the other players. So we really have, when I say almost no restrictions on what you can do with the VM, I'm talking about as far as like your VM doesn't even really need to be a proper blockchain if you don't want to. You can have like a subnet that just is like almost like a different version of IPFS and just like gossips things that aren't even state. So our virtual machines can be written in any language, and then the plug into a gRPC interface that Avalanche Go provides, such that it, if you want it, can provide a series of functions for you, a consensus engine, a gossiping engine, a network layer, and a state storage layer. And then you can interface with that in any way you want to. So a very common idea that has come up lately has been, hey, let's create a subnet, everyone run bare metal servers, and we'll run an EVM with like 150 million gas limit blocks at a 1 second block rate, and we'll target like 4,000 TPS. And because the subnet is fully isolated from the rest of the network, so you don't have to participate, people that participate like do so on their own volition. And if there's a ton of stuff happening on the subnet that doesn't affect the primary network, can kind of just like YOLO run whatever sort of thing they want, and it will have no effect on the rest of the network, which may be good for the trade-offs you're looking for as an application developer. I think the last part there is just the reason why, well, then why do it on Avalanche? The immediate interconnectivity with the other subnets is the hardest part of building like a blockchain. Typically is trying to connect to others. Like we have a very popular bridge with Ethereum to Avalanche, and not as many people can afford to create something like that, nor do they have like the intellectual capital around to try and invent something like that. So providing that as a native feature as a blockchain can be very useful for your growth, if that's what you're interested in. And so long story short, with a subnet, you can build a blockchain in like a matter of weeks instead of in a couple of years. We did the hard part. You can just borrow our parts of the stack that take a lot of time and a lot of auditing to make sure that they're good to go. So that was long-winded.
No problem. Thank you, Patrick. I don't know, Gabriel, if you have anything to add on?
That was great. No, that was perfect.
Okay, cool. Yeah, so a question we have collected ahead of time is regarding like the Avalanche position towards Ethereum, especially Ethereum 2.0, and also when Ethereum become more scalable with the optimism or the rollup like OP rollup and ZK rollup. What's your guys' thought there, and what's your strategy?
Yeah, sure. I mean, to say that we don't think highly of the ETH community would be pretty hypocritical, because our most popular virtual machine is EVM based. And so we're huge fans of like everything Ethereum is doing, and like the fact they really took us from simple asset transfers all the way to like general computing framework for anyone to use. And in my mind, really kicked off quite an era of innovation of like all sorts of things people really didn't even have the wildest ideas of. I think when I first heard about Ethereum, everyone talked about if you passed cars on a highway, you could like send them a micro payment for like letting them pass you on the highway. And I was like, if that's what we're, I think that used to be on their website. I was like, if that's what we're aspiring to, is like creating these things, it's like, I don't know. But like, as always with these sort of platforms, is people create things you never really imagine. So Ethereum to us was huge there, and obviously it's a huge part of the DeFi ecosystem now, and anyone is building something on an Ethereum virtual machine. Now, where we go from here, I think is very interesting. So I'll actually touch on the second thing you mentioned first, which is the rollups and the ZK syncs and everything like that. I actually have multiple friends, as you may imagine, that work at all sorts of different things kind of going on in the space. I think eventually people will be left to decide what makes sense to them, I guess, as the mechanism that will actually scale up the ability to interact with blockchains. Now, there are no doubt shortcomings of everything, us, rollups, anyone like that. Rollups, for people that aren't intimately familiar with them, the idea is very simple. You deposit to some contract on a layer one, something, or interact with it, and then you can use, some representation of what you deposited in this separate state space that is somehow faster or just separated from the rest of the network, that relies on the security of the layer one it's connected to provide, checkpointing to the people that are involved and make sure that if something happens, you can exit and get your money back. Now, the mechanism in which that is done is pretty complicated. So complicated that it scares the shit out of me. And I think people are doing really interesting stuff to prevent that. But like, for example, if you were to exit, it's either Arbitrum or Optimism. I forget exactly which one works this way. I think they both work in it the same way in somewhat of the case. But when you try to leave Optimism or something, or Arbitrum, let's just say L2, you will submit a withdrawal request. That withdrawal request will basically has a 7-day challenge period for it actually to show up on the layer one. Now, the reason for that is if there's a fault in the execution by the sequencer in the L2, which is typically just one node run by, one of these L2s, someone has to be able to claim that fault. I think Polkadot uses the term fisherman, and I think people have used similar terms all over the place. People looking for issues that they can then report on the main chain to get some reward. Now, how that works is you then take what you believe to be the attributable fault, deploy the state around that fault onto Ethereum, and then you run a bisection protocol to understand what opcode there was a disagreement about, and then you have Ethereum execute that opcode. Now, obviously, this is not optimized to be run tons of times, and the hope, is that you don't really have any faults on these L2 systems. But if you look just of like, what's all this trouble we're going through just to try and like separate the state space and rely on this L1's like security story, I just think it's more interesting if you can have some way to make sovereign blockchains communicate on the same level, where they can somewhat define their own security. I think there's a lot more at play here than trying to restrict everyone to build on this massive stack of state like abstracting structures. So it comes to like some level of kind of what your preference is in terms of an engineer or system designer of what you actually feel safe interacting with. And there are certain mechanisms people are trying to do to make that UX better or easier to understand. But I guess my take is more interesting that like, I think that sovereign blockchains have a brighter future than kind of these rollups on top of Ethereum as this like shared security layer. I just think there's so much more flexibility by not having to implement everything you do as something that can be rerun and verified by the base chain you're running on. It just gets crazily restrictive when you actually get down to it, unless you're running like some version of the EVM or something very close to it. So it's an EVM lover's dream. And if you think blockchains stop at the EVM, like you would love L2s, you'd love ETH2, and everything like that. But we think that our edge is providing a platform for people to build their own virtual machines that maybe change some of the trade-offs, change some of the narratives, try to optimize things in other ways to achieve different performance characteristics. So we think there's a multi-chain world. Obviously, the whole point of Avalanche is that we're connecting all these subnets. We're not trying to be this single virtual machine that everyone uses for everything that like slowly eats up the whole world, but creating a place for people to actually build their own and have tons of them interact very easily. So we think that ETH obviously will exist for a very long time, and some people that really like what the EVM provides will love it. But we think that there's a whole new avenue, different sorts of virtual machines that you can really only build on Avalanche.
Awesome. Yeah, thank you for the answer. It's great. So now I just want to switch direction a bit. to focus more on the Avalanche ecosystem. So a question I got is, what's the project like the most fascinating, or the project that excites you the most, that's built the Avalanche ecosystem, is part of the Avalanche ecosystem, and also another could be the same project or could be a different project that actually, because of the different traits you described, the subnets and all the different things that or advantages that Avalanche provides, that kind of enable that kind of project that they were not able to do in other, say, like Ethereum.
I'll chime in initially here, but Gabriel is pretty close to these folks and spends a lot of his time with them. So I'll also make sure he has time to chime in here. Two things. Obviously, I'm biased. We got a few very cool things VM related coming up pretty soon that I think we have been laying the path now for a while to really push people towards building very complicated VMs, but really want to get more reference examples out there. So most of the really interesting work has been smart contract related, less so subnets and custom virtual machines, but we think that will change in the next 3 to 6 months, probably pretty dramatically. On the C chain though, I think what people have really seen take off is taking things that are generally popular on Ethereum and then adding an extra twist to them, but because of the speed and the cost efficiency of what we do, have seen much quicker growth than their typical counterparts on Ethereum. So the example I'll give here is Trader Joe's, a very popular DeFi app on Avalanche. And obviously, none of this is ever investment advice. Like, I'm just curious in the technology and what people are doing. I have to say that because I'm very neutral with the projects that integrate with Avalanche, and all the ecosystem projects are great. But recently, I think yesterday or 2 days ago, they passed Uniswap v2 in terms of volume for any sort of DEX. And they've been growing very, very methodically over the last year or two, or not year or two, Jesus, like 6 months, yeah, maybe 3 months, have been growing very quickly. And people have very much said that the speed of the transactions and the ability for you to interact so frequently with it just speeds up the value creation cycle that a lot of these projects are doing. So when it's a fraction of the cost, like 1/10 or 1/100th of the cost, and the feedback you get is 10 seconds or like 5 seconds or even 3 seconds instead of 10, 15 minutes to get finality, you can start to really speed up the cycle of interaction, investment, like playing around with all these DeFi protocols. And so we've just seen a lot of projects that have catered to the Avalanche specific audience and people that are interested in exploring what you can do with faster block times and a little bit more responsive interface to really push it a little bit. Gabriel, I'll let you obviously chime in. I'm sure you have some opinions here.
I think you're muted.
I was muted. Yeah. So there's a lot going on. I think there's a couple ways to approach that. So I think some things that are happening in our ecosystem that are worth mentioning is that we have the Avalanche X grant program, which is a grant program, obviously, for giving grants to projects. We also have the Avalanche Rush program, which is an incentivization program for getting the so-called blue chip dApps, the Curves and the Aaves, for example. And then we also have this new Avalanche Blizzard, which is like an investment fund. So sort of independent even from the apps that are being launched, we have a lot of infrastructure and ecosystem support. So if you're considering entering our ecosystem, there is available capital for entrepreneurs. So perhaps if that's something you were wondering. With regards to actually dApps, I think there's a lot of really cool stuff going on. So right now we are obviously in the paradigm of DeFi. And as Patrick mentioned, there's a big opportunity to take existing Ethereum developer ecosystem and port it over. So for example, Pangolin was a fork of Uniswap v2. SushiSwap got forked over as he mentioned, Trader Joe. That's funny you said 2 years, Patrick. That's hilarious. It has literally been like 3.5 months. It's crazy how fast things are moving. But as he mentioned, they literally just passed the Uniswap v3 as the third largest DEX across all the different ecosystems. I think there's been some really unique stuff I've seen launch. So Flashback is a NFT ticketing dApp, which I think, I'm looking for stuff outside of DeFi right now. Obviously, DeFi is amazing, but in my opinion, the blockchain has the potential to be as meaningful as the web. And so I'm looking for other non-DeFi use cases. It's one of the reasons I love our architecture with virtual machines and subnets, because we're going to see non-DeFi subnets launch. So I think gaming is a killer app. We've been talking a lot with different gaming teams and companies, and there's just a lot of interest. I think a lot of people are waiting for that killer app to launch where you can use crypto for the payment rails, and then you can tokenize in-game assets. I think there's also exciting stuff happening around identity and privacy. And then there's also, I think I saw three that come to mind immediately. So we recently launched a partnership with Deloitte. I think that one's probably worth mentioning. We also, two that were in Mexico. Oh gosh, so many just came to my mind. The Chivas NFT. So Chivas, which is the Guadalajara, I believe, football team, one of the oldest in all of Mexico, celebrated their 115th anniversary by launching an NFT on Avalanche, did an auction. That was cool. Recently, there was some artwork of a mural of Kanye West was launched as an NFT. We just announced Particle, which are like ways to tokenize bits of an NFT that just got announced. There's also, we saw in Mexico, so basically there is like corruption is a problem in this part of Mexico. So they are basically tokenizing different, I'm not familiar with this workflow, so the words are sort of elusive to my brain, but basically like if you go to court, all of the evidence is being tokenized so that it can be proven through each step of the litigation process that there was nothing that got messed with. Obviously, initial litigation offerings are huge. Litigation is a 10 billion a year asset class. Bringing somebody to court is obviously so inexpensive. The barrier to entry is very high. We are now tokenizing that and allowing people to, raise capital for litigation through a token sale. And then at the end, if there's any, resources gained through the litigation action, you can, divide it amongst the token holders. We saw like a COVID passport system in Mexico, also built on Avalanche. So there's just so much that barely scratches the surface. Go to ecosystem.avox.network and just marvel at the nearly 400 dApps which have went live in the past 14 months on Avalanche. It's crazy.
Yeah, it is crazy. Totally agree that a lot of things we talk about, like the DeFi NFT, actually happened or become popular or developed in the last 2 years or less. So it's
yeah, we recently did a partnership with Tops where we did an MLB NFT marketplace. Patrick's been super involved in this, and also Bundesliga and Godzilla, and then MLB Now, where you can tokenize a moment in the game. Just so much going on. We think that Avalanche has the potential to be the premier the premier platform for licensed NFTs. So that's something we're also putting energy into as well.
Awesome. So I think Patrick and Gabriel probably in the presentation already mentioned or answered partially the question, but in case you guys want to add another point, so there's a question from Saeed. What is the main advantage of Avalanche or other L1 chains that are trying to dominate other new computation layer blockchains, for example, Solana, FTM, Luna, etc.? And will there be one winner or multiple L1 chain, and why?
Yeah, so I mean, I think this is the classic question, right? Like people are looking at a lot of these right now. I mean, what was explained to me, maybe a year ago or a year and a half ago is, I think people saw this coming, that VCs and people just in general via ICOs or whatever had poured a ton of money into a very large, or like a very, I guess not like a very large opportunity, small number of players that are almost directly competing with each other in almost every way. And so for people that aren't in the blockchain space, you may not appreciate the level of competition and how much people are really pushing each other to do their absolute best work. Now, Avalanche, people know us, a lot of people know us as like, oh, they just have another EVM thing. Like it runs on a different consensus model, just like, FTM and Phantom and just like Celo or whatever. Like, it's just EVM plus like slightly different sprinkles that they convinced some VC to think about like a year or two ago, and like all of a sudden they're all live at the same time, and like they do basically the same thing, maybe 1 to 5 seconds finality, and try to get a bunch of validators. The thing that is different about Avalanche is the abstraction and architecture we use to grow from the initial attention. Now, I don't know if this point is really like highlighted as much as I think it should be, but for everyone else listed in the example that's posted here, there's a single virtual machine that is just trying to grow. So like either that's growing by state, it's growing like slowly by features, but it's like the idea that there's like this single application specific understanding and people deploy things to it or they interact with it in a very specific way. And to change that dramatically is very difficult, probably more difficult than people realize that don't interact with this every day. You spend all your time talking to external parties to help them understand how your protocol works and how they can interact with it. And like all the little tweaks and knobs they have to turn to like really make their experience special, specific to what you do. Now, if you wanted to change what you're doing dramatically, you basically toss out like all these people, or you make the burden of integrating so expensive that they have to continually rewrite everything that they're doing all the time. Avalanche, with this multiple VM construct, like the C chain is our opening act. Like it's something that is just like one example of 3 virtual machines that are already on the primary network of a single subnet. Like all these other ones, like that's it. It's like the Solana VM, like that's it. Like the FTM virtual machine, it's just the EVM, like that's it. Luna, it's like a Cosmos SDK thing with a couple extra things on it. They're doing cool stuff with like burning tokens and everything, but like that's it. And they can interact with different Cosmos things, but that's all you get with them. And what we're trying to do is really take the experience of building a blockchain and change it forever, such that the people that can have the opportunity to do it when they may not have otherwise can really push the envelope of creating all sorts of different virtual machines that talk to each other. So the big difference to me is everything else, a lot of the other, not everything, but like a lot of the other L1 chains are focused on the now, and they've made decisions that optimize for like the EVM and making the EVM usable right now and maybe a little DeFi here and there. Us, it's about the longer term picture of how do you create this internet or this ecosystem of value that can move effortlessly across a very diverse set of different virtual machines. Now, will there be one winner or multiple L1? I'm very much, this is a controversial question for some reason. I'm like so obviously in the camp of like, there's going to be a ton of different chains. Like, what do you know about in your life where there's one of it, when there's a lot of people involved? Never. I can't even name one example where that's the case. Like Mac versus Windows versus Linux, like iPhone versus Android versus what, like there's not a single thing I can think of where there's like one de facto and like no one else even considers anything. There's just so many smart people doing so many different things so quickly with so many resources. I just find it inconceivable that all of a sudden one person could develop some crazy solution that no one could even come close to replicating. And everyone just says, you know what? Like Jim really killed it. We're done. Like everything's done. Like that guy's the best. Like no way I'm touching that. Anything else mine. Like shut it all down. It just sounds crazy. So I'm like talk to a Bitcoin maxi about like whatever like new chain you're trying to launch and say like, would you ever go to Bitcoin for this thing? Like that'll tell you everything you need to know. Like it's going to be a multi-chain world and people are going to keep doing crazy stuff. It's a really exciting time for people that are really interested in distributed systems.
Awesome. Thank you. Yeah, you good. Okay, sure. Thank you so much. It's already 7:02 and 10:02 East Coast. I want to respect everyone's time. Thank you so much, Gabriel and Patrick, for coming in today and sharing with us about Avalanche and the ecosystem, the technology. So thank you so much. And thank you everyone for joining the event.
Thanks for having us. It's been a blast. Yeah.
Take care.
All right.
Thank you.
Bye-bye.
Cheers, you guys. Thanks, Patrick.